Today you're going to do another unit test. You're going to do something that has a bit more to do with classes, and we are going to test something which is a service. So this is kind of just, we're only focusing on creating a service, and we will work a lot more with services as you move forward. So I just decided to make a small test for day 2 where you have a simple service you need to implement, a credit service. The credit service has a class called credit. I'll show all of this in code in a second. And that credit class contains some properties. And that's kind of to show you guys how easy it is to work with properties in the C# environment. And the rest of it is not implemented. So we have to figure out all of these. And of course, I have unit tests to try and make this work for you. Now, a lot of the unit tests will end up actually throwing exceptions if you don't put in the right data. So that's what I want to show you guys just as a quick example today, how you can get those exceptions thrown inside your code so that you are ready to make the unit tests green again. So here we have the code that I downloaded. And here we have the credit service tests. And let's just, I'm not going to stay here too long, but I just want to show you guys, we have 4 main areas right here we're going to focus on. And if I expand this guy right here, add credit, you'll notice that the first test I have in here is that if I add credit with a negative value, I'll return an exception actually. Let me just try and see if I can zoom out a little bit. There we go. So the first test right here explains to me that I need to make sure that in my production code, if I try to add credit with a negative value, so it's less than 0, it should actually throw an argument exception. I can see that right here. Not only that, I can actually also see that that argument exception needs to have the message of credit to add must be 0 or more exception. That's the text I need to add. So I can read this from the unit test. Again, if we can't see it all, let me just try and scroll a little bit further out here. There we go. There we go. So that's the unit test that we need to kind of solve. And first of all, right now I've added all the methods, but they're not implemented. So to solve this specific unit test right here, let me go to add credit. And the first thing I'll do is I'm getting a value, and to make the first unit test pass, I had to say, if the value was below 0, I need to do something. I need to throw an exception, right? So let's take the value right here and say, if value to add is less than 0, right? That's where I need to throw my exception. So I'll throw a new exception right here. And now it's important that I check out again, what type of exception do I need to throw? And that's right here, an argument exception. Copy that, or you can write it manually. So it needs to be a new argument exception, because here we are talking about a new class that I'm making an object from. There we go. So now I'm throwing the exception if the value is less than 0, but I'm not quite there yet, because it also says that it needs to have this. Let me just go to it. It needs to actually throw an exception that says credit value to add must be 0 or more. So that's just a constant string right here. So I'll just add that to the exception. And that's very simple. You just get the constant exactly like you do right here. You get the constant class, and then you put in whatever string you want to get from that class. So let's take constants dot credit cannot be less than 0 exception right here. I'll add that, and I'll save this. I'll run all my unit tests. I just want to rebuild the solution so I can run my tests. And hopefully I can now run my tests. Run unit tests. Now this might be different on the Windows version, but you should already have tried running unit tests yesterday, so it should actually be quite easy for you to do. Now, right now I'm hiding all the successful ones. Let's just get rid of that and show all the successful ones. And now you can see this one is now passing. The constant credit to remove must be 0 or more exception has now been solved. So the point is just that some of these tests will be solved by adding Let me just get rid of that so you guys can see some more of the screen. Some of these tests will be solved by actually adding information like this, where you throw exceptions if things are wrong. And some of these tests are basic calculations, because when we are done testing that the value is in the area we want it to be, then of course we just add the credit. And just to show you guys how easy that is, I just want a current credit value. That's one of the tests. Let me actually try and show it to you. And then I won't help you anymore. It should be one of the default tests, I think. So current credit value returns 0. This one won't pass right now, so it should be down here somewhere. There it is. This test fails right now. How do I make it pass? Well, let's just try and go to the service again. A credit, what is that all about? Well, a credit, let's try and go into that class. A credit is just a basic class with 2 properties. So this is how you make entities or basic model objects inside the .NET framework, inside .NET Core and inside C#. What I've done right here is very simple. I've made 2 properties, and notice there's not a getter method and a setter method like we're used to in Java. And there's not a private property like you're used to in Java from our point of view. But behind the scenes, C# actually builds all of that for you. So you just don't see it, but it's actually there. And that's pretty amazing, because if you want to later on to make this like you're used to in Java, you can actually, at any point in development time, you can change this, and you can change the getter. Like if you wanted to automatically calculate to a currency, you could actually go in and change that. I'll show examples of that later. And the same with the setter. If you wanted to maybe decalculate the currency again, whenever you save this to the database, you could do that in here, just like you would be able to do in Java. So you just don't need setters and getters up front, but if you need to do extra calculations later on, you can always do it. They're just as safe as they were in Java. Okay? They're just easier to read, in my mind. Another thing that's worth noting is that notice that the value is uppercase. Properties are always uppercase. Again, in Java, you might be used to lowercase, but here they're uppercase because they are the public variables right here. So they are available from the outside. So how do we get the credit value in the service? Well, it's very simple. I just need to say return credit. That's this guy up here. The credit, that's a local property right here. Now notice this is a private local property. So here I chose to use lowercase. So I'll say credit dot value, and then I have the value for that credit, and that's all I had to do. Now the second test runs as well. So that's kind of the assignment. And yes, I know that exceptions are kind of scary, but you just have to play around with working with these exceptions. And I've added a few exceptions in the lessons from yesterday. There are exceptions, so you can go and check out that code if you want to, and there'll be help there. Or you can go and just check out the exceptions again inside the actual unit tests, because each unit test will again show you exactly what exception I expect you to throw, and also what text I expect it to actually return inside that exception. Yes. So I had a few great questions, and there was also some terrible questions. No, I'm kidding. There was mostly great questions. And the first one I kind of mentioned, or I was asked, was, what does this mean? Let me just try and write credit dot value plus equal, and then value to add. So this is, again, not, this syntax right here is also used in Java. So it should be something you've all seen before, but it's pretty much just a way to avoid having to write something like this, which will give you the exact same result. So it's a way for me to not have to write the same name twice. That's pretty much all it gives you, okay? And I need to say, when I add credit, I want to take the current credit value and add the value I want to add, right? So that's kind of what I need to do. And then if I want to be a smartass and make it simpler, I do it like this, and I have the same result. Okay, so that's what that is all about. Some of you also had questions about the remove credit. The general idea is still the same, that we can do the exact same thing right here with a minus instead of a plus. But, whoops. And then I need to, of course, say value to remove. But of course, you need to consider that the value to remove should not be higher than the credit value, or else you'll get a minus. And in my bank account system, that's not allowed right now. So you need to handle that with exceptions, like you can see in the tests. Actually, that's a valid question as well. So you can do both. You can do plus equal and equal plus. And it's actually not important in this case, but it's to do with, do we read the value first and then calculate, or do we calculate the value and then read it? So that's kind of what you are looking at right here. If you have plus equals or equals plus. So in some cases, it makes sense if you want to read the value before the value is added, then this would be the solution. And if you want to read the value after the value is added, then this would be the solution, okay? But in my case, it doesn't matter, because in the unit test, when I'm done adding this, I call this function. And at that point, this will be updated no matter which one I choose. There we go. I was asked the question, what if I actually want in a property to use the getters and setters for something specific, so they are back to the private way you're used to in Java? Well, I think the easiest way for you guys to learn that is if you jump into important links, you jump to the tutorials class site, and you find the class right here. There's actually a pretty neat example of the class right here called my class. They have some properties, and here is one of the properties you've already seen me use right here, public int. They call it my auto-implemented property. But behind the scenes, what it'll actually do is create a property, something like this. And that's how you guys, if you want to later on change your properties, you can change them like this. So let's try and do it with the current setup. I'll jump into my code again. I'll find my credit one right here. So if I at some point, I figure out that this one needs to do some extra work for me, I can actually, again, use this example right here. I can make a private property. So let's just make a private one. That's not how you spell it. Private. Let's call it either just lowercase value, and of course it needs to be a double value again. Double. I need the U. There we go. Some do it like this. When we have private variables, we use underscore and then the name, or you use lowercase. It's really up to you. I don't have a preference, but some people do have preference right there. A lot of times there will be a syntax the company assigns to you how you should do this. I think what I've seen mostly is the lowercase right here. But in this example, he doesn't use lowercase. Then what you can do is you can actually, instead of returning the default built-in setup, you can actually go and create your own one. So inside my get right here, I'm going to change it around. So now the get will actually be with curly brackets right here and return the value. There we go. Now my get is set up. Let's just make that a few lines so it's easier to read. And now I can do the same with the set. Now the key point here, and here I can do anything. I can say this one equals. The thing you have to do is to put in this value keyword right here. If you don't do that, you will actually not get any value set at all. So this is what the machine does, or the code is, the code that's generated behind the scenes looks like this, okay? So this means that from the outside, I can still use this public property. I'll get to the chat in a second. I can still use the public property, but whenever I want to change this, if at any point I need to make some private modification to this property, I can do it at any point without affecting anybody using the public property. Does that make sense? So that's why properties are available, usable, and you can still work with private setup if you want to later on. Great question. What is the underscore thing? Well, it's actually just a naming convention, so you don't need it. You just need to use the same name all over, right? But it is a naming convention that some people likes private variables in C# to be underscore and then the name of the variable. It's not required. In this case, however, value is a very bad name, because if I put in that name, notice if I remove the underscore, I'll actually have the exact same name right here and here. That would mean that I would have to kind of assign this, and using the this keyword, I could point still up to this guy right here. So that's why if I put in the underscore, it might be easier for you to read like this. So that's the property, and that's how you use properties. And if you later on want to extend them, it's fairly simple to do that without affecting anybody else in your code who uses the property. And that's the point. So I'll just keep this for now. Of course, what I could do is, let's say I had a currency of some kind, and let's say I wanted to say the currency was 1.3. I could actually, whenever I get the value, I could calculate with 1.3 now. Okay, so now I have an intelligent property right here that can do stuff now in my code. And here I could also do a validation before I set, if I wanted to. Everything I do in the credit service right now, like this one, I could actually do that inside my set method right here if I wanted to. So I could say if value is, the value from the outside is less than 0, I would actually throw an exception directly inside the property if you want to do stuff like that. And that's the same you're used to in Java probably, where you can do with the set and the get property methods, you can change these things. So this is a possibility if you want to use it. But again, look how nice and simple the code looks when we don't use this syntax from the beginning, because we don't need it. I am a fan of actually using these validations inside the credit service instead, because it's a lot easier for us to kind of move our unit test into a business logic layer here, which is the services. Instead of putting it inside the models, it makes it easier for us to see there's more transparency in the code, and it's easier for us to kind of get the business logic in one place. Instead of having it in some models and some of it in some services, we put all business logic in the services. So that's why I actually still recommend having DOM entities like this with just properties, and then move the logic into the services. I want to talk a little bit about the Trypass, which is something we're going to use. Okay, so let's try and jump into code, and I'll try and show you a Trypass. So I'll just make a method right here that gets a string. So again, yesterday what we did was we just did the int pass like this, and we passed in the value. Now this will, of course, work if you pass in a number, and that means if you do anything like this, so if it's 5 or if it's minus 18, something like that, it'll work, right? No problem. But if we pass in a value like b, it'll fail. So that's what the Trypass can do for you. This guy will actually not, it will throw an exception right away. So if you mouse over right here, it'll actually throw an exception, argument null, format exception, overflow exception. So you have to handle exceptions here in this case. What if we don't want to do that? What if instead we just want to have a true or false value if it actually passes? To do that, you need to use the Trypass, and this is where it gets kind of weird. So first of all, what do I want to return? Well, I want to return an int value. Let's just use int instead. Let's just call it return value or passed value. That's maybe a better name. Passed value. And I'm not going to initialize that value. So I'm not going to equal it to anything yet. I want the Trypass to initialize this value for me in case of success. So what I want to do right here is I want to say if, and then I'll say int the Trypass. And here's where I'll first pass in, again, you get information up here about what to write. First, I'll pass in the value, which is value 1. That's the one I want to try to pass to integer. And then the second parameter is where do you want to put it if it's actually allowed. Okay? So if I get into this if statement right now, I'm not done yet, but if I get into this if statement right now, the value is an int. Okay, it passed. But you'll notice I'm getting an error right now, and that's because in C# out of the box, you're not allowed to pass, you're not allowed from functions to change values inside the function. And you probably tried to test this in the swap exercise or in Java. You'll see that if I, in a method, pass in a value, the value would be the same when the method is complete. Does that make sense? If not, let me try and show you. if I, for instance, for this value right here, I go and change that value to snurf like this. Okay, so here's the question. At this line right here, what do you expect cheese to be? Whoops. Would you expect cheese to be snurf or cheese, right? Because I pass in the value right here, and in this method, I change that value, right? So what would it be? Would it be cheese right here, or would it be snurf right here? So at this point, after I've sent this value right here into the Trypass test, do you expect that value to actually have changed to snurf? Or do you expect that value to still be cheese like the original initialization? 50-50. No, actually it wasn't. Because as I just said, just like in Java, you're actually not allowed from a method default, you're not allowed to change whatever comes from the outside when the method is executed. So that means if you just follow this step by step right here, I go in, I define a variable called cheese, I send it into the method, so I go up here. Now it's actually cheese, right? So now the value 1 is cheese. I move forward, and at this point, I change value 1 into snurf. So now value 1 is actually snurf. And if I use it inside this method, it'll be snurf, right? For the entire method, it'll still be snurf. But as soon as this method is done, it'll be back and it's again cheese. But with C#, you can actually change that. You can add a small keyword right here called out. And that actually means that you are allowed to change the value inside the method. Okay? So I just want to mention that. So that's when you do use the Trypass, you have the value you want to change, and then you have to send in a value which is an out value, meaning that inside this method, I am allowed to change this. So that means that if the value is an integer, then in this case, passed value would actually be equal to whatever value. So if I pass in 5, it'll actually return 5. And if not, I'll just continue. I'll just skip the if statement and say nothing happened right here. You could also use this inside a while loop. I could say while in Trypass. So while that does not pass, I can keep going. And I could, of course, now ask for a new value all the time, right? So that's what we're going to do to make a menu. If you try and put in anything that's not in the menu, like you put in the letter J, where you have to pick 1 to 5, it'll say you can't pass that. So just ask question, try again. You need to put a number. You need to put in a number, right? So that's the Trypass. Enums, I just want to give you guys a short introduction to those as well. You probably use them in Java, but you might not like them because they're just strange to use or something like that. So I just want to show you what it takes to use enums inside C#. And again, this time I'm pretty much almost sure there was one about enums right here. So this is how you make enums. They are fairly simple. And we can try and make an enum over here. You can make an entire class for it if you want to. And you can also have an enum in an already existing file. So I can make a new enum right here. So let's say I had different credit types. I can make an enum right here. And again, you have a full setup right here on how you set it up with the syntax. So let's say credit types. So we could have loyal, that's a loyal customer or something. So now we have an enum right here, and of course we can make that public, and that makes it possible for you guys to actually start using these enums in switch statements and stuff like that. So if a credit had an enum, I could use it here now. I could say public credit type. It'll be of the credit type's enum type, and then I can call it just credit type. Credit type. I'll do a getter and setter. Okay, so now it's available for my credit. And that pretty much means that if I want to go again and create a new credit, here's where I create the credit class. I can now actually go in and add a new type right here. I'll do a comma, and you'll notice we can use credit type equal and then credit types dot, and I have these different ones to pick from. Let's make this guy a loyal customer. So now we have used that type. And then in order to kind of figure out this credit, what kind of type is it, you could use a switch statement. Let's just try and do it in my new method down here. Let's try and just do a switch. Switch. That's how you spell it. Double tap. And then I can say, I'm going to get a credit from the outside right here. So I can say credit dot credit type. That's what I want to switch on. That's what type I have available. And then you can start doing the cases, right? So again, this is just like Java. We say if the credit type is loyal, then I could maybe console write line. Something like this. You rock. I'm happy, etc., etc. So that's how you can control these different switch cases. And again, we have also examples of switch cases in here. And go and read about the enums. You can see you can actually define yourself what each value is. And actually, the example I have for day 4, I've made some completely crazy menu enum. Yeah, go and check that out if you want to. You can see some crazy ways to use it, right? Let's just find the switch as well. Here it is, and there you can go and if you are if you can't remember how to use the switch, here's a few examples on how you can actually use that switch. So that's the enum and the switch statement, and there should be plenty of examples for you to use. Here you can see using a switch statement with a basic integer, and the different cases are available right here. Here you can see using the switch statement with a string, and you have the different cases again right here. So you can use switch statements, and don't be worried about the switch statements, but if you really hate them, you can do everything with if-else statements instead. Okay, so it is possible, but it is kind of cool to learn about the switch statements. Final thing is arrays and lists. So here's the list, and just like with Java, lists are now generics, and that means that when you make a list, you need to specify what type you're using inside the list. So let's just try and create a list right here of credits. So I'll make a list, and I'll say credit. That's what the list contains. I'll call it credits, and I'll make a new list right here of credits. And that's kind of how you create a list like this. Then with a list, just like in Java, you can add to the list. So you have different ways to add. And for now, just accept that there are some pretty basic things you can do right now, but soon I'll present you guys to something called link. And that means that we can start filtering, sorting, ordering, cutting up lists. We can do some crazy things with lists using the link framework, which will be presented later on. But right now I could add the credit that I just passed in the parameter right here, and that's how easy it is to kind of add to the list. And then you have for loops. You do for each loops. I think that's also available in Java, so it's not a big thing. I can add here the credits. And for each credit, I'm going to get an item, and then I could console write line that item or whatever I wanted to do. So that's how it works with the lists. You could also make arrays. That would be a credit array like this. And of course, it also needs to be a credit array on the other side, but it would be easier just to do this as a var, and then it would know that it should be a credit array like this. And if you use it like I'm doing right here, I would actually have to specify the size of the array. Now that's the difference between lists and array. It's easier lists are easier because they will automatically expand for you, right? That's why we normally use lists all the time. But it also comes at a small memory price because it always keeps duplicating the size in most systems. Okay, so that's why it's a bit more expensive than an array, but an array you need to kind of yourself maintain the size of the array, and it's a pretty much a hassle. But actually in C#, they've helped you. And if you go to array, you can go and check it out yourself. There's actually a few things you can do that makes it easier to work with arrays, just like you're used to in lists. So again, there's a lot about arrays right here. How you initialize them. Here you either go in and you initialize an array where you say it's an int value with the size of 5, or you can do just like with a list. So in my case, if I want to get back to, instead of calling add right here, I could actually do it like this and then say, I want to initialize this with the credit right away, like this. Then it would actually be an array containing that single credit now that I have available.